Okay, in the photoelectric effect, a photon with an energy of 5.341 times 10 to the negative 19 joules. This is going to be my energy of a photon. Strikes an electron in a piece of metal. So basically we have this piece of metal, the photon hits it, and an electron bounces off. Okay. Of the energy, of this energy, 3.562 times 10 to the negative 19 joules is the minimum energy required for the electron to escape from the metal. So this is basically the ionization energy, right? How much energy it takes to remove that electron from that piece of metal here, okay? We have this piece of metal, we're pulling an electron right off of it. And then it says that the remaining energy appears as kinetic energy. What does that mean of the photoelectron? That means that this, it's just like the speed of the electron. The kinetic energy is energy of movement, right? So it's going to be the speed, the rotation, the vibration, all that kind of thing. So how do we find, what are we looking for here? Well, let's just read the last part of the question. What is the velocity of the photoelectron, assuming it was initially at rest? Well, let's find, if we're trying to find the velocity, that's going to have something to do with the kinetic energy. So let's find the kinetic energy. So kinetic energy is going to be equal to the initial amount of energy, 5.341 times 10 to the negative 19 joules, minus the energy it took to knock it off of the piece of metal. So 5.314 times 10 to the negative 19 joules minus 3.562 times 10 to the negative 19 joules. And that will give us 1.779 times 10 to the negative 19 joules. So that's our kinetic energy. And we have this formula that says that kinetic energy is equal to 1/2 times the mass times the velocity squared. Okay? Well, we're trying to find the velocity. We want to find this guy. So if we rearrange this equation, we find that v squared is equal to the kinetic energy. That would be divided by the mass, okay, and multiplied by 2. So then the velocity would be equal to the kinetic energy over the mass times 2 to the 1/2, right? So let's figure this whole thing out. All right, so this is going to be, so velocity is equal to kinetic energy. That's 1.779 times 10 to the negative 19 joules. Uh-oh, I've got mass in here, don't I? So I'm going to have to convert that joule into units that involve mass. So I'll multiply this by 1 kilogram meters squared seconds to the negative 2 per joule. Now my joules will cancel, and I'm in that unit. Okay, good. I'm going to divide it by the mass. Well, what's the mass? What are we looking at? Oh, we need to have the mass of an electron, don't we? Well, it turns out that the mass of an electron, let's see, where should I put that? I'll put that here. Mass of an electron is going to be equal to 9.11 times 10 to the negative 31 kilograms. Okay, I wouldn't expect you guys to memorize that number. If that's something you'll need, you'll be given it. Okay, so then we're going to divide by that, 9.11 times 10 to the negative 31 kilograms. And then up here we'll multiply by 2, that's right there. And then we're going to have to take basically the square root of this whole thing. Okay, when we do that, I got 6.250 times 10 to the 5, and that's meters seconds to the negative 1, because as you see here, hold on. Yeah, so if we just look at the units here, so first of all, the kilograms cancel, right? The joules cancel. Now we have meters squared per second squared. But we're going to take the square root of that, right? So if you take the square root of meters squared over seconds squared, well, you end up just getting meters per second. Okay, so that's what our answer is here. And that's all there is to it.